Welcome. Still just trying to thinking, do I have everything lined up? It's always difficult to get my setup like just the way I want it. Get all the stuff set up, get my soldering stuff set up, get the camera stuff set up. And this is a more complicated today because I am going to be doing some hot air rework stuff. So I have got power supply and oscilloscope, soldering station, and a hot air rework station here. So and hopefully I can get this back to where it was. So I'm continuing with this CPU card that I designed. It was, what was it, Sunday? Sunday was the last day I was working on this. I took a little bit of a look at some things, tested some things on Tuesday, and then came back, and this morning I was testing things and trying to figure out what was going on. The short of it is the CLPD was not programmed, and I went ahead and put all of the chips, including these transceiver chips, on, which I probably shouldn't have done. I should have at least programmed the CLPD first, but even more important, I did not include the pull-ups for the output enable of the transceivers, which, yeah, I should have thought about it a bit more. In order to prevent the transceivers from turning on all at the same time, there's some of them, particularly these three at the top, only one of them can be on at the same time, and these two on the bottom, only one of them can be on at the same time, at least if they're writing from the card to the bus. Because they're writing into the same pins, so with the chip unprogrammed, it wasn't pulling them up, so it was active low for all of them. They were all therefore writing into the same pins, and it was pulling quite a significant amount of current. I may have damaged things, but in doing some tests today, I put a program into the CLPD that will allow some of the I/O pins on the serial port that are just wired straight to the CLPD. I could make those. I could use jumpers to select whether it was these two or whether it was these two, which one of these two or which one of these two was going to output onto the bus. And doing so, I was able to at least test to see that putting power to these individual pins, these are the data pins on the CPU, and these are the address pins on the CPU, which are wired essentially straight to the transceivers. I was able to make sure that I could put a value onto these pins, and it would go through the transceivers, and I would see it on the bus, and I would not see I tested a few adjacent pins just to see if giving power to one and ground to an adjacent pin would make them both go to ground or both go high, meaning that there was an internal short on one of the transceiver chips. So I was able to determine that it probably was not, they're probably not damaged, or at least not significantly. There was crosstalk, so if you do put power onto one of the pins, since the other ones are floating, it can induce a bit of current on the adjacent pin, or a bit of voltage, enough to switch the I/O for the transceiver, so the output is like adjacent pins will be if you pull one high, then the adjacent pin will be high, but if you actually connect that adjacent pin to ground, then it is not high. So, and it's not pulling like significant amount of current, so that tells me that there isn't an internal short. So I'm not going to try removing the chips entirely, but there was a weird thing where if I press down on the chips, it would draw like a couple, like 100 or 200 milliamps extra, which is a little nervous. It makes me a little nervous. So I figure I might as well dig out the reflow and give him some heat, and we'll see if that improves things. If that makes that go away, if it just sort of makes the solder flow more nicely. But I could also totally fuck it up even more, so we'll see how it goes. This is also the first time trying with this thermocouple. I have a thermocouple on a helping hand, resting above the chip that I'm going to start with. So the idea is, as I am using the hot air to blow around the part, I'm going to make sure that I'm getting to the right temperature and not too much, not beyond the right temperature. But I've also noticed that if I move this thermocouple cable a little bit, that it is winking out the value. It stopped, like it'll go to a couple hundred degrees Celsius and then go lines like the bottom. This is a 2 thermocouple meter, and I only have one of them connected, so yeah, I guess we'll see. Just testing my audio as well. I went and recorded a whole bunch of stuff on Sunday, and then found out that the audio was all messed up. So, hoping that doesn't happen again. It sounds fine though. So, I'm gonna turn my my solder station on. I'll just leave it at 3. Oh shit! Before I do that, I was going to switch the end here. So I'll go back to my flat tip, which is, now that I look at it, it is a bit dirty. And last time I had to re-tin the end with some stuff. I probably don't really need it because I'm not going to do much, but figure I might as well. And then I will turn on the hot air rework. Let's see, it's set for 300 with 50% air. So that should be fine. And my monitor keeps going off, which I am really unhappy about. I thought I had fixed that, but I guess not. This is probably just going to be a short session because it's going to be dinner time soon. But I just want to see how this will go. Also, other things that I ran into was that the clock, it's supposed to be a 50 megahertz clock, but it ends up going at like 16.66 megahertz instead. So, and I was playing around with the resistor on here. It's a 15K resistor. And looking at some of the other ones, they use like a 1 mega ohm resistor in there. I don't have any 1 mega ohm 0508 or 0805s, sorry. So I will have to do something with it, but I'll probably just end up like pulling it off and then holding a 1 mega ohm on it. But yeah, we will do the this first transceiver first, and trying to get this thermocouple right in the right spot is being a little difficult. I also noticed that it has a bit of what looks like solder on the end. I hope that is not solder, because that'll probably melt and go flying everywhere. So I might have to change thermocouples. I can already tell this is going to be a little difficult. I mean, a little as in, like, that's an understatement. Already needing to reposition this thing because the hose is not really long enough to reach to the other side to really properly get that top bit. And our temperatures are not very high here on the thermocouple. Like, if I get it right on the end of the thing, then we're getting the right temperatures, but otherwise not really getting up to temperatures, so don't know if I need to give it a little more temp or a little more air. And it keeps going out, which is really convenient. Honestly, this is not fucking working at all. Getting in the way while I'm trying to just see this stupid thing. It is quite difficult to see. From my angle, it almost looks like the pins have like it's not quite aligned vertically. And I don't know if that's because I was messing with it or if it was not aligned to begin with. Or if it's just those top pins, because the bottom ones look alright. I don't know. My thinking was like, I'll try this and see if I can make them reflow a bit, and then I'll try adding the pull-ups, because otherwise I will have to remove the pull-ups, because I was planning on putting the pull-ups like here. The reason I need the pull-up still is because if I reprogram the CPLD, the outputs go into input mode. They go into high impedance mode for the duration of the programming. So it would still be like the chips would end up writing into each other every time you program the CPLD, which is not the best. I'll try a little more temp. Try 365. And I'm just gonna move to this next chip and see if it is any different. Now you're supposed to like gently heat up the board. But with the microscope in the way, it's kind of difficult to do that. Well, I mean, I can smell the flux, so there's that. As I keep sticking my head in the camera. Well, I think it did melt the solder, at least. I'm not entirely sure it got every pin there. There's one that's discolored. I'm kind of curious if, like, well, specifically that capacitor, which is a little crooked, I'm kind of curious if I can get it to reflow. Oh, that's interesting. Seeing some bubbling on the back side of the RAM chip. I guess I'm getting that a little too hot. Alright, well that definitely was moving. It just wasn't like... I mean, it did sort of realign. I was expecting it to snap a bit more. I wonder if I've like killed the board by just putting too much heat on it. I'm inspecting this top chip and I see that the pins are they don't have a lot of solder. They do have solder, they just don't have a lot of solder. Every now and then I come across solder joints like this where it looks like it looks like there's like I haven't soldered it, but I'm pretty sure I did solder it. And then I think like, oh, should I resolder it just to be sure? I mean, it doesn't look that bad, but it's going to be really hard to do this later on, which is why I think, oh, I should just resolder this. And I may be out of solder. The one nice thing about having the thermocouple there is that it actually tells me where the view is. So it's a little easier to make sure that I keep things in shot. I also need some paste or some flux, and I did not buy new flux. I need to. I was gonna do a DigiKey order to get some more some flux and some more CPLDs and other things that I need, including some 1 megohm resistors. But it's like, I don't want to put an order in until I know all the problems with this board, so I know I've got all the parts I need. Well, I definitely did see it, like, pop. Ow. A little toasty still. I mean, it looks like it has more solder on the pins. Still not a lot of solder. Kind of hate this thing, to be honest. I've come this far, I might as well do all 5 chips. Suppose since I'm gonna put flux on, I might as well just put flux on. Anyways, I was saying, yeah, I'm gonna buy some more no clean flux. They have DigiKey has some liquid no clean flux, which is I'm like, I really like the liquid stuff because this tacky stuff just is so sticky, so tacky. But haven't put the order in yet. When I do, I will get some and possibly some flux remover, but they only have like a $50 bottle of flux remover or a, what is it, like, it's the usual kind of ridiculous thing where it's $56 for 500 milliliters, which I think is like 63 ounces or something, or 22 ounces. Versus like a small little bottle, a 1 ounce bottle that's $20, $22 or something. So pay twice as much and get 22 times more cleaner. Even though I don't really need that much. I'm sure I'll use it eventually. Alright, let's see. Still getting temps good. Let's see what this looks like. I really should do the whole, like, gentle heat up. Also, I hope the fan noise is not overpowering the voice. I see some flux coming out, or some flux coming out the bottom, so it's a good sign. That side looks a little dull by comparison. I'm sure it's fine, but it just... anytime I see like a difference in color and traces, I think, oh, it didn't work. I mean, it's soldered, but it might not have actually reflowed it. That side looks good though. Looks fine. That was maybe a little too much flux. Oh, wow. Hi. Thanks for the raid. Did not expect that. All right, have a good evening. Thanks. I guess the rest of you can watch me totally bodged reflowing. I'm trying to build a CPU card here. This is a 68030 based CPU card. And I realized that the design that I have, I need to have pull-up resistors on the output enable pins for these transceivers. And so before I try and solder on some resistors, I figured I would try and reflow these chips, because I just hand soldered them with a soldering iron before, and now I'm using a hot air rework station. Ooh, that's... maybe a little much. This is like the third time using this hot air rework station, so I don't know what I'm doing. Just visually inspecting to see what the result is. The fourth chip didn't actually like shift. I was expecting it to maybe shift a little more center because of the like being heated up, but maybe I didn't heat it up enough, get all the pins loose, or maybe it just didn't decide to do that. Either way, how hot's the boards? 50C still. I'd like to do a quick check to see if we're getting anything. Tacky flux. All right. Power up here. I did not prepare well enough for this. I was having problems earlier with my oscilloscope probe, so we'll see if this works at all. Or if I have to change the probe. Get our power here. right, which pins were we on? So I'm testing the data transceivers. I need to put jumpers on, would it be low on both? Yeah, and then that will turn on the data low, I believe. Okay, so we should be on the lower pins, which means data 7, which is that one. Nope, that's not it. Are we on the other one? Would be 24, which is that one. We've got power. Untangle this. Okay, this is supposed to be data 8. Sorry, data 8. Data 8. Looking up on my drawing, data 8 is actually that guy. Ah, there we go. Okay. 9 is that one. Okay. So it would be that. Yeah. And 24 and 25 should not change anything. So this transceiver should be, if you can see here, that transceiver should be on, that transceiver should be off. So this transceiver would output data line 8, data bit 8 to there. And we don't have anything right now. And if I touch power to data line 8 on the CPU side, on the bus side, we are getting the signal come through. And going on to data line 9 and doing the same pin, we don't see any change. So we don't have shorts between those. And then it would be 24 data line, oh, lost one of my jumpers here. There you go. So data line 24 should not change anything because that transceiver should be off. So that looks good. And if I switch our signal to the CPLD to turn on the lower transceiver here and turn off the upper transceiver, we should see on data line 8 no change if we try and give the CPU side some voltage, and that pin should change with D24. All right, so that's still good. I could check the rest of them, but I guess I should check the rest of them, or check just a few spots here. I'm especially curious about these address ones. So let's see here, the address ones. I am turning the lower one on and the upper one off. Something like that. That should be address pin 1. D17. So this is the cross transceiver. Let's see if D17 does anything. That is the 6th of row 2. Is that one? That one. Okay, so that's working. And then we should not see anything from address line 1 on the CPU, which is 4 over 2 down, or 4 over 3 down. That one. Okay. And if I switch the transceivers, we should see that change. That is working. And our D17 was 6 over. Good. Okay. I am satisfied with that. Didn't make it worse, at least. All right, cleaning up a bit. Power supply off, disconnect. Get that out of the way. All right, so those transceivers have been resoldered. I feel like if I'm going to try and rework those resistors in there, I should probably like glue them down, but I don't have any glue. They're probably going to be a pain in the ass to do. I will change my soldering tip. Actually, wait. Before I do that, I will solder the USB connector here, because I'm going to need to get those pins. everywhere. Just check my audio again. All right. So we'll put a USB-C connector on. Get some flux. Really? Got some of them. It just doesn't really want to heat this up though. This is also my first USB-C connector. I've done micro USB before, but never a USB-C. And it has quite a few pins by comparison. Also, I need more flux. It looks good. I mean, good enough. Checking to make sure it's flush with the board. These pins aren't sticking very far through, so... I guess it would be prudent to also solder the top side of these pins. Need a bit more flux here. Alright, I'm gonna change the tip of my iron. Does anybody have a preference for seeing the trying to solder some resistors on here, or soldering sockets? Soldering maybe the big socket here. I've got to put these 3 sockets on, and I have some push buttons and LEDs and stuff, but I'm may or may not bother with those. I guess I'll give a resistor a try, but I'm expecting it to be really finicky. Where the heck did it go? Ah, there it is. Man, these things are tiny, and these are 805s. I probably should be using like, well, these ones are 0603s, and that's 0805. I guess my options, I could technically try and go on the back, but I would have to like scrape off one of the vias and then solder to one of the vias. I thought it might be a little easier to try and solder to the pin here, since it's the top pin that resistor would need to go to, but I also need to not short it to the pin below. is going to be a challenge. I don't expect this to go very well. Also, it would help if I had some flux. I mean, that looks like I jumped the pins, right? I think getting the right amount of solder on here is going to be next to impossible. It still looks like the pins are jumped. The solder wick needs some flux as well, or the solder is just not going to go into it. Kind of hard to see there, but oh yeah, those are still jumped. Honestly, that still looks jumped. Surprisingly, the top pin and the second pin are not jumped, but the second pin and the third pin are jumped. Honestly, they still look jumped. It's going to be easier to look at the pins. L1 is actually, or pin 2 is L-word. Which is that one. What's that? Oh, okay. And pin 2 is going to be A1. Okay, that's good. That's not go on that one. There we are. All right, I think that's good. I think we don't have a short there. So the other side of that resistor would need to connect me being completely disorganized right now. Get a little bit of wire. We'll have to connect the other side of this resistor to power. And obviously a good source of power are these two pins here. We could just like wire wrap onto there. Let's try it. Give ourselves that much. Alright, so I've just got a little wire wrap tool here. So that's connected to there. And then it's a little long, but whatever. I'll cut off a little bit of the this part, the exposed part of the wire. We just need a little dab. Onto there. Maybe a little too much solder, that's maybe not enough solder. Let's see how this goes. Oh. Surprisingly, that worked. I thought it was gonna like not go on and or desolder the other side of it. All right. So let's check resistance through this. Now this pin is actually going to go to, this is the output enable for the transceiver. And this is going to go down to the CPLD, and conveniently it looks like it is, I guess I could switch. So this is the transceiver we're looking at. We just put a resistor onto MD32X OE, and that pin is going to run down to the CPLD, the bottom pin, the bottommost pin on the left side of the CPLD. So we would expect that looking at that pin, oh, over here on the CPLD. Switch back to that view. We should see 10K to our power pin. There we go, 10K, 9.7, close enough. So that means we are, man, that's very. Ah, there we go, that's better. Yeah, so looking at our power, 9.71. So that is working. That's nice. I had been thinking of like daisy chaining them up, but that was also really annoying to do, so I'm not looking forward to doing the rest of them, Jesus. You know, I guess for the sake of like minimalism, we actually don't need a pull-up on every one of them. It's only these two transceivers that would write into the same set of output lines, which would short them if they were both writing out at the same time. But we could leave this one without a pull-up, which would make it write, and while the CPLD is being programmed, it would be outputting, and this one would be disabled. So that should prevent the chips from getting so hot that they burn my fingers, which is what happened on Sunday when I last was working on this. So in the interest of not having to do every one of these ones, I mean, technically we should do 2 of these 3 because I believe they are all outputting onto the same signals. I'm kind of like, as I'm doing this, I'm kind of rethinking, well, maybe do I really want to be able to program the CPLD while this is connected to the backplane, which maybe not, because I'm going to do a revision of this board. I'll respin the board once I get this all like known to be working, once I know that all the other problems are sorted out. So I'll just have to remove the board if I ever want to reprogram the CPLD, because it will be outputting addresses onto the bus while it's doing the reprogramming if I don't put that pull-up on there. And the other one is the other 2 are the A40 cross, so that's if you want to be able to do the A40 cycle, and then the D16 cross and the data low. So the top one's data low, the middle one is the D16 cross, so that's taking the, what is it, the upper address pins of the CPU and putting them onto the lower address pins, or the lower data pins, I should say, of the bus. This is because the bus is a 16-bit bus and the CPU is a 32-bit bus. But if you were to do a 32-bit operation, then these two transceivers would be on and this would be off. And normally if you're doing a 16-bit operation, just this transceiver would be on. Is that even right? Maybe that is not right. So the top transceiver is U14, and then U13, and then U12. Oh yeah, so the A40 would be on only during the address phase, and then when it switches to the data phase, then it would turn off, and the D16 cross and the MD32 transceiver, which is on the bottom, would be on. So it would be this second one and the fifth one would be on at the same time. And then the third one here would only be on during the address phase. And otherwise, if you're doing just a 16-bit operation, then only the top transceiver would be on. So I should put pull-ups on 2 of them instead of all 3. Well, I mean, I should do 2 instead of 1, but for the sake of simplifying my life, I should do 2 of them. Does it make a difference which one we do? I suppose it doesn't. I suppose it doesn't. I am going to do I'm going to do the second and the third one. Okay, we'll start with some flux. I'll stick some flux on the other one while I'm at it. A little bit of solder on our tip. Switch hands. Also, I have a lot of little cords around. All right. Well, that's certainly stuck on there. Question is it shorted? Did I short pins? I mean, no, but not super well secure, but whatever. This is just a stopgap anyways. I will do both of these and then put wires on, because I'm gonna do like a daisy chain wire along rather than going all the way back and trying to wire wrap more onto that same pin. Well, those seem like secure. And I don't think they're bridged. Second one, or the first one, doesn't have a heck of a lot of solder on it, but I'm not going to bother. I break too many things trying to be too perfect. I need to learn not to do that. This is just rough rework. Also, it's really difficult to get this wire into the stripper. Here we go. Almost could be a little shorter. Not as smooth as the other one. Damaged the wire a bit, but that's okay. I need a bit more wire. So going from here down to the next one. That should be enough wire. Suppose I could be more gentle with this. My distances. Like that, isn't it? That's going to be a little long. did it to there. Like a centimeter off, maybe. There we go. Okay, it's a little crooked, but whatever. Oh, I need some more space, actually. So, how about that? A little more. There we go. Just didn't want to lay flat. Suppose before I do that, I should put a little bit of flux on. Ouch. Nothing like a little burning sensation. This is tricky. Phew. All right. Let's get back here. Those don't seem to be going anywhere. Let's see what we got now. So we should be seeing from 5 volts, 10K to our MD32 pull up. So that's working all right. And I need to look at the PCB layout again. So the other ones we did were A40 and D16X. So that's going to be the 3rd and 4th pins on the CPLD. Man, can I even get my probe onto just that pin? A little hard here. Doesn't help that I have problems seeing. I would say that looks like that's the right pin. And that would be the other one. 9.9. Okay. So we are getting the resistances we expect. Now we want to just check to make sure that there's no unexpected shorts. So from that pin to that pin, we have no short and no short. From this pin to here, we have no short. And then it's just the other pins there. Do we have like a bridge that's messing things up? Would be V8 and V0. VD8 and VD0, which are these two top pins. Well, that's right, and that is not shorted to that. Okay. And then this one. If I'm on the edge of the resistor, it looks like we're not shorted. All right, I'm going to call that good. Phew, that was annoying. My garbage, collect all the little bits of wire that I cut off. All right, there we go. As a reward, we get to do sockets. Actually, As annoying as it is to have that thermocouple in the way, it actually like reminds me, oh hey, that's where the camera is pointing. If you, if I'm not soldering right there, then nobody can see it. All right. So these are our other parts. We have a pin grid array socket, a PLCC for there, was that 32 pin PLCC, and a 44 pin PLCC. And then we have the big connector, but I'm probably gonna save that for another day. I should put the reset button on, but I may not bother putting the user buttons on, because if this is no good, if I have to respin the board, why waste a button? I mean, it's a couple dollars, so it's not a big deal, but I have the LED too. I'm gonna do those later. I'm gonna do the pin grid array first, because it is the lowest profile. The PLCCs are slightly higher. Okay. Oh, I have those little capacitors underneath as well. I put four caps on the underside of the board. These are just bypass caps. I should probably put those on. The question is, should I do it before I put the socket on? Yeah, I should. Answered my own question, didn't I? Those are the 06 and 3s. Looking for my caps. Here we go. 0805s, 0.1 microfarad. This is the last few. How much did I buy? About 100. I have more. This is just the last time I bought some. Forgot that the socket was in there. Need to spin it around so that I can reach properly. Keep reminding myself it doesn't have to be absolutely perfect. I get too obsessed with making them exactly aligned. Probably if I use hot air it would be fine, but... Okay. Now the pins on the board are kind of making it so that the board doesn't want to lie flat, but I want it to lie flat on the socket to make sure that it's putting enough pressure to hold the socket flush to the board. See if I can't get it more in focus. Here we go. All right, so starting with one pin, I just want to tack it in. To keep the socket in place. And bridge a pin. All right. Get some flux in there. Ugh. 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 This flux. I need to get some liquid no clean flux. I have liquid water soluble flux, but not no clean. I'm gonna put flux all over as well to keep the thermal load on the socket, on the plastic of the socket. I try and jump around from pin to pin instead of doing them all in order. Hopefully that makes it a little less likely for the socket itself to get damaged, for the plastic to, you know, melt, and then the pin isn't fully connected to the socket properly. And so, yeah, jumping around a bit here. Hopefully I have it on camera most of the time. Not enough flux everywhere. A lot of flux. I'm sure I'm going to get myself in trouble at some point with, like, just totally forgetting to do a pin when I jump around like this. For those who don't know, this this socket is one of the harder things to find. Phoenix Enterprises is the only place I've found that will sell brand new, what is this, 128 pin socket? You can't find one of these at DigiKey because it's obsolete. And while you can find plenty of 68000s and 68030 CPUs, both in pin grid array and in the surface mount, you can't easily find the sockets to go with them, which is pretty annoying. I believe the socket cost me about $10 with shipping and duties and everything. And you can buy a brand new surface mount 68030 for $10 on eBay and stuff. eBay and AliExpress. I specifically wanted to, like the previous board that I made used a the surface mount version because it's so much cheaper. The pin grid array versions are like 30 to 50 bucks a chip, and the surface mounts are $10, but you can't easily remove it once you put it on the board. I mean, you can take it off, but you can't necessarily reuse it. So, because I have a CPLD on this board, I figured I would try the pin grid array. That way I can remove the CPU while programming the CPLD, which is rather convenient, especially for like testing right now where I could just directly start putting power onto these pins and test those transceivers. I swear, I've got to find like a better way to solder those things because they're just so error prone, so finicky. The 48 pin TSOP packages. I suppose before I get too far, I should actually like check and make sure I'm not doing any damage, make sure everything's aligned. Solder's coming through nice enough. No melting. All looks good. So yeah, this is going to be the first board that I do with the pin grid array. I'm sure it'll be fine. Bridged pin there. Just give it a bit of heat so that the solder goes through the board. I've got enough flux on here so the solder will get sucked into the hole and make it through to the other side. Not sure if I can show it on camera. Probably not very easily. Better there. Not really wanting to focus. It's kind of hard to see, unfortunately, but you can see just a little hint of solder coming through the board. Oh, hi. Patrick Close 007. Are you sure the jumping around doesn't cause more stress because each section now expands and contracts multiple times? I honestly don't know. I've tended to have more issues with pins being like the pin inside of the connector itself melting and falling out of the connector or not taking the chip properly. So that ends up being like more of my concern than thermal stress. And I've already today put quite a lot of thermal stress on this board with my very bad hot air rework, hot air reflow. I did use the thermocouple, but I did also just like pump tons of heat into the board. So we might find that it's completely fried. Which is all the more reason not to put that VME connector on, because until we like properly test everything. Because I believe that's a $10 connector. And better to not waste it than find that the board doesn't work. Looks like we don't have enough flux there. Honestly, I probably should have also like gotten the higher temp boards. I assume this is like the 135 TG 135 or whatever instead of 155. Or 185. I think the 185s are available. But I got the cheapest board. think I'm going to finish up this connector, and then I'm going to take a break for dinner. That might be all of them. Few sloppy trails. I'm just looking for like any ones where the solder is there's a trailing piece of solder coming off of it. Like that one. Can I show it on here? Did I lose it now? I think it's that one. Man, you can't really see it. It's that one. It does look a little messy. I did maybe use more solder than I should have on all of those. Sounds like my food's here, so I think I'm gonna call it there. I'm gonna be on later tonight. Probably take a break here, and then come back and solder these two PLCC connectors, sockets. Oh, I need to also fix the clock. The clock was running poorly. It was running at 16.66 megahertz instead of 50 megahertz, and it's probably that little resistor, so I will resolder that. Oh, thanks for the follows. I hope you enjoyed. I will hopefully see you again later. Like I say, I will probably be back in about an hour if all things go well. And then I'll finish this up, and then we can maybe put some power onto the board. I don't know how much farther we'll get. We might not put the CPU on yet, but we might be able to see if the USB works and stuff like that. But yeah, thanks for the raid. Thanks for joining. I will see you in an hour or so. Bye.